Hi, and welcome to section 1.2. We're going to talk about addition in this section, addition of whole numbers specifically, and their connection to a real-world concept of perimeter. So, a couple of objectives we have in this section. We're going to do some addition when there's no carrying involved. In other words, when there's a one-digit sum, like 2 plus 3. And then we're going to look at some addition where there is carrying. So, in other words, where the sum is more than a single digit. So, classic example is 9 plus 1. What do you get? You get 10. And so, in a sense, what we're doing when we make 10 is we're carrying from one place value to the next, showing that this place value is full, and we can essentially trade our 10 ones out for one 10 unit. Then with part C, we're going to look at applying some properties of addition. Those are these properties right here. And right there. And then we're also going to look at solving some basic equations, and we're going to look at some perimeter problems. So this is an addition table. It's sort of like a multiplication table in that you can use the rows and columns to as the addends, right? The parts that add up in a number to a sum. And so here you can see that there's this value of 10 that occurs whenever you add, say, a 9 and a 1, or an 8 and a 2, a 7 and a 3. So these are the important pairs. And in fact, let's just go through all of the unique ones. A 6 and a 4, and of course, a 5 and a 5. And so if you keep going, you're using the same numbers, but in a different order. So instead of 6 and 4, you're looking at 4 and 6, but the components are still the same. So these are the ways to get to 10. 9 and 1, 8 and 2, 7 and 3, 6 and 4, and 5 and 5. And so whenever we have these, we know we're going to sum to 10. And that can help us to break down lots of addition problems, and especially when we have to carry. So we'll come back to that a little bit. Let's define what a sum is. A sum is the result when we add two numbers. So if we add two numbers a and b, then the sum is a plus b. So to find the sum, we just add the numbers. So the sum is the result of addition. So let's try some adding problems here. So example 1, add 43 plus 52. 43 plus 52. Now that's how it's written originally, but they say we want to write this vertically because when we write it vertically, we line up the place values, and it can help us to stay organized and to keep the ones with the ones and the tens with the tens. So what I do is I start with the smallest place value, in this case the ones, on the right, the 3 and the 2, and I add 3 and 2 is 5. And then I go to the next column, the next place value, which is the 10, so 4 and 5 makes 9. So the result, the sum, is 95. So 43 plus 52 is 95. Now, we can do that with bigger numbers. So 165 plus 801. I line up my ones, my tens, and my hundreds, so that way I can more easily add. 5 plus 1 is 6. 6 plus 0 is 6, and 1 plus 8 is 9, so 966. Now we're going to add some bigger numbers. Now the only thing that's different here really is that I have to be sure to line up my place values such that the ones are always lined up, and that will make sure everything else is lined up actually. So what I'll do is I'll start on the right and I'll add my ones and I'll see what happens. So 9 plus 0 is 9 still, plus 4 is 13. Well, 13 is a two-digit number, so it won't fit in a single place value. So what I do is I write the ones place, right, the small piece, and instead of writing 13 with the 13 here, I write 13 with the 1 up top. I add it to the tens because I'm going to have to add it in with these others. Now, when I add here, I'm actually going to add in the tens place, I'm going to add the 1 and the 9 first because 1 and 9 makes 10. So that's going to be easier for me. Plus 8 is 18. Plus 6 is 24. And what I do is I keep the ones, even though it's really in the tens place now. It's the smaller number, right? The smaller place value of what I've just done here, 24. So I keep the 4 in this column and I push the 2 into the next place value over. When I add here, I see that 2 and 8 makes 10 in the hundreds. Plus 7 is 17. Plus 4 is 21. Carry the 2. 2 and 6 is 8, and 2 is 10, so that's a 0. Carry the 1. And 1 and 4 makes 5. And now 1, 2, 3 places in is where I need to have a comma so I can show the separation between the thousands and the hundreds place. So the result here is 50,143. So next we come to the addition property of 0. And the addition property of 0 is actually pretty intuitive. It says that if you take any number and you add 0 to it, you'll get that number. That number won't change. So if I take a number like 6 and I add 0 to it, I'll still have 6. And this property, of course, works in the reverse. In other words, that if you have 0 and you add 6, then you get whatever you've added because you started with nothing. So your result is whatever you added, whatever you increased by. So in words here, adding 0 to any number leaves that number unchanged. And you might think, well, why is that useful? Well, for a couple of reasons. One is that it makes addition faster, that we know when we add 0, the result doesn't change. And it's also handy because later on, we're going to need some of these properties in order to solve some problems. So we'll see how it all fits together. Another important property is the commutative property of addition. And the commutative property, just sort of like it sounds, commuting to work. It says that, let's say I work here, and I live over here. In the morning, I go to work. And in the evening, I go back home. That distance is the same. So the order in which I go doesn't impact the result. The distance is still the same. And that's how the commutative property works. It says if I have two numbers and I'm adding them, it doesn't matter what order I add them in. The result is going to be the same. 2 plus 3 is 5. 3 plus 2 is 5. 5 is 5, no matter what. And so in this example number 5, they want us to use the commutative property to rewrite each of these sums. And so I'll just show you. I'll show you with an example like D. Actually, we'll just jump right into D. 7 plus a number n. N could represent some number. Well, if I want to use the commutative property, that just says change the order of the terms you're adding, and it won't have any impact on the sum, any impact on the result. Another property of addition is the associative property. And just sort of like it sounds, to associate means that it doesn't matter whether when you're adding 3 or more terms, you add the first two or you add the last two first. If you're adding up a bunch of things, the result's going to be the same. And we could look at an example like 2 plus 3 plus 4. It doesn't matter whether I add the 2 plus 3 first and say that's 5. 5 plus 4 is 9. Or I add the 3 and the 4 first. 3 plus 4 is 7. 2 plus 7 is 9. Okay, so those are the same. Now, you might know about the order of operations that says we need to go from left to right with addition and subtraction. But in this case, with everything being addition, we can invoke the associative property, and we can essentially add things in the order that makes the most sense for us. So in some cases, that means adding up to sums of 10, like we were looking at in one of the first slides. And so in this case, they want us to rewrite some of these expressions using the associative property. So if we have something like A, which says 5 plus 6 plus 7, well, 5 plus 6 then plus 7 is equivalent to 5 plus 6 plus 7. And while they sound the same, they look different, but they actually mean the same thing. They're equivalent. Now in this next example, we're going to try to find the solution to each equation by inspection. So this means that we need to know some of our addition facts. So let's look at A. A number plus 5 equals 9. So what number, when you add 5 to it, gives you 9? Oh, 4. So the number must be 4, because 4 plus 5 gives you 9. Let's look at another one. Let's look at D. 13 equals a number plus 8. So 13 equals what plus 8? Oh, has to be 5, because 13 equals 5 plus 8. And so you can always check a solution. You can always check the solution to an equation by seeing if it's a true statement when you plug it in. Now let's look at some geometry applications. A polygon is a geometric figure with at least 3 sides. So some common ones are the triangle, the rectangle, the square. Square is a special kind of rectangle where the length and the width are the same. But it's still a rectangle, it's still a right angle, right? The triangle's a little different. The triangle is sort of like half of a square or half of a rectangle. And the perimeter of any of these shapes is adding up all the sides. So in the case of a triangle, adding up A, B, and C. So the perimeter here is A plus B plus C. Or a rectangle, where there's some length and some width. And so the perimeter here is equal to, well, you've got two widths and two lengths. So it's usually called twice the length plus twice the width. So that'll add up the four sides. And then, of course, there's the square with some side S. Now, we only need to label one side with a square because we know that because it's a square, all four sides are the same. So the perimeter of a square is equal to just 4 of the side. So that's pretty neat. So let's use that knowledge to find some perimeters here. So let's look at A. The figure is a square. Because the length of each side in the square is the same, the perimeter is, we know if one side is 15 inches, that side's 15 inches, that side's 15 inches, and that side's 15 inches. So there's 4 15s, right? So the perimeter is 15 plus 15 plus 15 plus 15, or we can think of it as 4 times 15, and that's 60 inches. Now, notice it's really important to have the units. Without the units, the number's just a number. It doesn't tell us anything meaningful about the size. Let's look at B. In the rectangle, 2 of the sides are going to be the same. So in this case, 2 24-foot sides and 2 37-foot sides. And so when we add these all up, we get a total perimeter. Well, let's add these up. So the way I'd probably go at this is I'd see the 7 and 7 because I know that 2 odds will make an even. So 7 and 7 is 14, plus 4 is 18, plus 4 more is 22. I think that's the easiest way to add that. And then I see that, 2 3s is 6, and 2 4s is 4, and 6 and 4 is 10, plus 2 more is 12, and I have nowhere to carry the 1 to, so it actually comes down in its own place value, so 122 feet. And now for C is not like the other two where some of the sides were the same necessarily. This one is a kind of an uneven polygon in the sense that it's got a bunch of sides that are uneven. And so when we add those all up, well, let's go ahead and do it. So 36 yards plus 23 yards plus 24 yards twice plus 12 yards. Try to get all the sides. So let's see here. 6 and 4 is 10, and 3 is 13, and 4 is 17, so that's 19. Carry the 1. 1 and 3 is 4, 6, 8, 10, 11 total over here. So 119, and of course I have to put my units so that I know what I'm talking about. This was C, and this was the math for B. All right, let's review kind of the key concepts from the addition of whole numbers section. So go ahead and pause the video here and take a stab at these yourself. Go ahead and pause the video here and take a shot at these, and we'll come back and do them together. So A, what number is the sum of 6 and 8? The sum, so sum is addition of 6 and 8. The sum of 6 and 8. 6 and 8 is, if I borrow 2 from the 6, Give 2 to the 8, that's 10, and 4 is 14, so 6 and 8 is 14. Part B. Make up an addition problem using the number 456 that involves carrying from the ones column to the tens column only. Ooh. So an addition problem with 456 that involves carrying from the ones column. How about this? Because 6 and 5 is 11, carry the 1. 1 and 5 is 6, and 1 is 7. So there was no carrying from the tens. And then bring down the 4, 471. So that'll work. There's my example for B. C. Explain the difference between the commutative property of addition and the associative property of addition. Well, the commutative property says that the order of addition doesn't change the result. And the associative property says that you can add the terms in any order without changing the result. Can spell there. All right. So that's the difference. And part D, did I leave myself enough room here? What is the perimeter of a polygon? Well, the perimeter of any polygon is the sum of all sides. Sometimes there's a nice formula and it's easy when all the sides are the same. And sometimes they're all different and we just have to add them all up. Hopefully you got something out of this and you're ready to do the homework in 1.2, and we'll see you back for 1.3.